So this multi-page application is developed for the current testing to automate tests and collect a uniformity of test data based off of readings from Wi-Fi testing, thermal testing, DOCSIS testing. Uh, I'll provide a quick overview of how to use this application. So right now we will have to go to the navigation to go to a different page for this multi-page application. This page here deals with CSV files, and it interprets CSV files from any folder, converts them to a data frame. So let's look at this here. So we can choose from any directory. So I will choose. So we have to assign a unique key for this file. This unique key is the key for this file, which is identical to the concept of a hash map. So this key associates the value of the contents to this file. So we'll assign this key as temp. You can see here it is a password encrypted input text here. So we have the data frame columns outlined here. We can see the raw data here. We have some options to the left sidebar. The data frame columns are listed here in a list format. So if we want to delete, for example, column 2, we go to here, click this, and click the delete button. The functionality here is outlined using a session state example provided from the session state framework provided by Streamlit. After that, the session state updates the current data frame to view the next subsequent step, which is to generate statistics based off of this report. After the statistics is generated, the session state will still keep intact of the current data frame to provide a plot-based example or scatter plots based off of what you need in terms of any unique or outliers that may be susceptible for error or something like that. So as we see here, we can edit the values of the axes. We can change plot color to whatever we want. This is downloadable, so you can click here and download plot as PNG. You can attach it wherever you like. There are more options within this plot functionality, so you can highlight a specific area to zoom in to view specific points, as I'm doing here. There's a lasso effect. You can auto scale back to see the full overview of it. You can expand screen to have a better view, and you can see plot by the values and the plots here. Scroll down, so we can title this generated data frame here. If we expand process data, these are the current columns after the session state has cached the information that we've deleted certain columns. If we try and attempt to delete the same column twice, placed a try catch here, column previously deleted, so it'll throw this exception or this message, this warning symbol out in front of you, mentioning that the column has been already previously deleted. Please select another column. So you can't delete the same column twice. The column that has already been deleted is cached already. So scroll down. So we can give this report here a title. So we can just name this sorted data. We can choose to generate the statistics in Excel, as an Excel file, or this data frame here as an Excel file. If you choose to do both, then you can do both. Click enter, generate statistics. You'll have a success prompt. So once it says data file created, that file is auto-named into your application directory. So if we look here, we can see sortedatom.txt. It was locked at this certain time. The stats version for that file that we uploaded. If you hover over it and you want to see the key, you can do that by this. So to the far right, it says temp. That's the key we assigned this file. I just printed it out right there just in case the key has been forgotten or something like that. So I'll demonstrate a quick example of a file with atypical encodings. Those files are usually something along the lines of this. They have titles or informations, which is kind of irrelevant when deciphering a data frame. So when these lines are here, it errors saying that the encoding is not correct. UTF-8 encoding errors. What you want to do is manually delete this stuff. If you didn't have this specific script outlined here. So if we upload that script, we'll go to, so at the moment currently, this file that you want to manipulate has to be in the application directory. So technically, when you're browsing for that file, you can technically move it. Like for example, if it were to be in some other folder, you can just drag it and drop it here. It will just make that step easier. We assign a unique key. It's best practice in the case that you're going to be combining these statistics or these data files that they have the same key. Reason being is that key will correspond to certain files which will later be combined into one Excel file. Temp is the key that I'll assign it. Same idea is here. So say we want to delete some columns. This first column needs to be deleted. Just click the delete button. So this is expand imported data. As you can see, this row 0 still needs some sort of modification. So we generated a new data frame which looks more cleaner, more approachable. This is user-friendly. You can scroll left and right. This is .head only, so you can only see the first 5 rows. This is the updated data frame columns. This is the original data frame columns. You'll no longer see 101CH. That channel is deleted in the updated data frame. As I mentioned, you can't delete it again because it's already been deleted once, and that information is cached in the session state. We'll expand process data and we'll no longer see that 101 channel here. If we did delete 10101 channel, that will also be reflected here in the updated data frame. This is called an expander, just kind of declogs your current interface. And then scrolling down, you'll be prompted to statistics, which will be available to download for the combined report. You can see here basically every column's count, mean, standard deviation, minimum, maximum, different quartile ranges, and any other data that might be of any use. Same concept between using the graph. So let's say we graphed channel 10102 and 10104. It's outlined, like, let's choose another one for, all right, let's choose another one. Okay, this seems more scattered here, not in a linear fashion. This doesn't seem like it has a line of best fit, so maybe there could be some errors, could not be some errors based off of what the engineer, it's their discretion. So we can see values on the scatter plot. We can see these outliers. This is very useful content. This can be downloaded. Can be zoomed in. For example, I want to see what's going on in this cluster. Let's zoom in more. You can see more data points. So moving forward, we'll title this app. We'll title this after the title is arranged, we can generate statistics. We can generate data. So once these buttons have been pressed, two separate Excel files will be generated on behalf of this fluke log here. You can check that in our application directory as we see here. There is a temp fluke log.csv. It was logged at 2022-07-14-1621, which is 4:21 p.m. ET. There's also a statistics generated here. Temporary as a demonstration, we'll only be working with these two files. So after the engineer decides that these are the files that they will be working with, and their subsequent step would be to combine them, we'll go to combine reports. So we have to keep track of the key that we used, which leads to the files that were generated in our application directory. So thinking back to hash maps, we have a key that associates to certain values. So for example, this one, so we can see, in case you forget, developer hack is, say, here. The very far right side, we can see temp as our key, just printed out there just for visibility purposes, just in case someone forgets. There's a S attached to the key value as an indication that it is a statistics file. That's also indicated at the very start. It says stat in capital letters. So, all right, so we'll type in temp. It should detect that there are some files. It processes the key. It outputs the current files with that key value. This specific key outlines to 4 different, or essentially 2 different data files. Those 2 data files correspond to statistics file generated from that data. So these 4 files are currently being combined. So we'll title that sheet inside the workbook that we'll be combining into. So we'll name this combined sheet 1. Click enter. We have 2 options here. We can save to an we can save this sheet, this combined sheet, into an existing workbook, or we can just create a new Excel file consisting of this. So as of option 1, we would need this to be in the current working directory. If there is an existing workbook, you would need that to be in the current existing application directory. So we'll click browse files. I have one saved here called dbt. So submit button to append Excel file into an existing workbook. We'll append these files there. So currently there is a quick procedure. There's a loop running in the backend, which combines / appends these files into that specific selected workbook. This takes just a second. While that runs, I'll explain a few things that are happening here. So this check here, say you did input an invalid key. Invalid key just means there's no existing files associated with that key. So instead of temp, I just typed in temporary or something else. Then the interface would prompt out as an error saying invalid key, no existing files. It seems that our files have been appended into that workbook. We can check that workbook by opening it up really quickly. So there we have it, combined sheet 1. We only were dealing with 2 files, so sorted atom, and then there was a fluke log. It has all the data you need. We also decided to combine the statistics. They're color-coded based off of the most important data that we need from them, the title, the average, and the maximum, outlined here. There's a 2-column gap between everything just for professional documentation purposes. This data is used by, once again, hardware engineers to validate that the unit is functional. It doesn't have any errors that need to be addressed. So we'll go ahead and close this for now. We'll create new just to save all of this into a brand new workbook. So while this loads, I hard-coded the name of this new workbook to be titled as combined, and then I'll log the current time. So for right now, it's 4:21, 4:27, along with, so it would be combined, and then plus string attachment would be just the current logged time of when this is being generated. This is useful context in a case where you can see here combine the logged time that is it has been combined at into this new folder .xlsx. So this also creates a new Excel file, a brand new Excel file, not an existing one. So we'll go here. We can see that here. So combine sheet 1 is the title. We named the sheet no matter where it is. This is independent of adding it to an existing workbook. It's not linear coding. Everything here is used. All right, so we'll X this out. So all of the files that we've generated, essentially these statistics files, these are all temporary. These temp, sorted atom, these statistics. We have everything we need into one, either new Excel worksheet, workbook, or we have something inside of an existing one. So we no longer have any use of these temporary files. This one, this one, this one, this one. That functionality is also in our application. Instead of manually having to delete these files one by one, here we could just click delete files. This is also a session state example. Once the first button has been triggered, we will be prompted to this error. 4 files will be deleted. Are you sure? just because we don't want someone to accidentally click delete files and everything gets deleted. That would be very, very poor user-friendly. That would be a very poor user-friendly application. As such, we need to store the fact that the first button has been clicked. So it needs to be cached in some kind of memory that the first button has already been clicked. Subsequent step would be to confirm that delete. As such, you would need to click the confirm delete button to thoroughly delete the temporary files. If we click that, the files will be successfully removed. You will be prompted to this success here. We can check that or verify that we no longer have those files. We're only left with that combined report and that DBT, that existing workbook. So we no longer have those temporary files that were generated using this application. I did not want to do that automatically just when running the script, because sometimes there might be a use case where certain individual files are necessary for further inspection. So that concludes the usage of this application. This can be considered as a tutorial. There's many backend stuff that I can explain. Please reach out to me in that case. My contact information is here on the homepage. You can reach out to me on LinkedIn by just searching up my name. So fluke logs. It's not always it's not always set in stone that there's 5 lines at the top of the page that need to be deleted. There could be more lines up or down that need to be removed from context when generating data frames. Otherwise, you wouldn't even be able to create the data frame because it would result in an error. It would say encoding error. That's why the fluke file interpreter script deals with atypical encodings for certain files. So what we do in the backend is the first 5 lines essentially get deleted. We open the file and we open a temporary file that we read from and write into. We do some low-level stuff along with reading and writing from files. And then we replace that old file with the new file that we create, which has the contents, the necessary contents, and not the information lines. This line can be adjusted in the backend. I'll come up with an update to change this on the application itself. The code is outlined here. Reach out to me if you want that. That concludes this video. Thank you.